A Chapter 3, Section 1 video if you're in our class and you're using our textbook. If not, that's okay too. Here is our essential question for the day. How can I simplify and evaluate expressions? So we're going to work on two things, simplifying and evaluating. And this might be a little bit introductory, meaning we're just starting it. But it all comes down to understanding what a variable is. So in class we've been talking about variables, and variables are typically a letter that stands for a number. So X and Y are ones that we use frequently. X is actually a number, we just don't know it. It's a mystery. And Y would also be another number, but we don't know it. It's a mystery. And one of the tools that we like to use in class is we use algebra tiles. So we use this thing called an X tile and a Y tile. And I want to introduce an idea to you. If you've used the tiles before, they're double-sided. They have a color, but on the back side, they're always red. And the red represents the opposite. It represents the negative values, the negative X or the negative Y. Now, if you're taking notes right now, hopefully you're writing all of this down. The challenge to this is you don't want to have to pull out markers or colored pencils every time you do these. Like having to color in the blue and the red and the purple, that would be a lot of work after a while. So we have a little bit of a shortcut that we use for our notes. I'm going to give you a key here to put on the side. Instead of coloring them blue and red and purple, what we often do is if we shade it in with our pencil, we call that the positive side. And if we leave it empty and white, we call that the negative side. So because we don't want to color it blue, red, purple, and all the colors, what we're going to do is we're going to make it in our notes look like this. We're going to shade with our pencil the X, and we're going to leave the negative X empty and white. We're going to shade with our pencil the Y, and then we're going to leave the negative Y empty. So that's kind of a key to kind of help you set it up in your notebook. Now let's try some problems. Let's do an example. So here's our first example, example 1. We're going to write down a problem, and it's 2x plus 4 minus x plus 1. Now we're not going to solve for x yet because 1, we don't have an equal sign, and 2, we just don't have enough information to do any solving. But we can do some other things. We can study this expression. We can draw a visual to represent it. A visual means we can draw the algebra tiles. We can think about what's 2x, what's plus 4, what's a minus x, and what's a plus 1. So here's what 2 x's would look like if you grabbed your algebra tiles. Here's what 4 units would look like. A negative x would be that red side, and a plus 1 would be another one of those little units. We can draw this picture in our notebook because it represents the expression. But we got to draw it like this with the shaded. We don't want to use colored pencils, remember? So we have 2 x's plus 4, a negative x, and a plus 1. But there's also some more things we can do with this problem. We can identify what the terms and like terms are. Terms are all the parts of the expression, so it's kind of like a list of things. In this problem, we have a 2x, so I could write that down as a term. We have a 4, we have a negative x, and we have a 1. So all I got to do is list them out and then put some commas in between them, and those commas just break it up so that it's a list. Those are the terms of the problem. The like terms are the ones that match, the ones that are the same algebra tiles. So for instance, 2x and negative x are the exact same tiles. One of them's just flipped over on the red side. So those are like terms. What about the 4 and that 1 tile? If you look at the picture, those are the same tiles. So they are also like terms. So we got our visual. We've identified what are the terms and what are the like terms. There's one more piece to this. We can simplify. Simplify means moving things that go together. And one of the things I notice is if I'm trying to simplify is there's an x and there's a negative x. What happens when you have a positive and a negative come together? What do they make? They make 0. A positive and a negative are like opposites. They counteract each other and they make a big 0. So that x and that negative x actually can be pulled off the map. They can be pulled off your table if you have it built in front of you. I'm going to draw arrows and put them over there. So my remaining answer, what am I left with? Well, I still have 1x. And how many little units do I have? 1, 2, 3, 4, 5. So I have an x plus 5. That's my simplified answer. Again, I haven't solved. I don't know what x is yet, but I can simplify it. I can simplify this big expression down to x plus 5. All right, your turn. You're going to try. So I'm going to give you a problem. It's 3x plus y squared minus 2x minus 4. And what I want you to do is I want you to hit the pause button on your device, and I want you to go through the work. You're going to draw the visual, write out the terms, write out the like terms, and then try to simplify. See if you can do all 4 steps. Go ahead and hit that pause button and give it a try. Alright, so I'm hoping you're unpausing the video, that you've done all your work, and you're ready to see if you got this down. If you've given it a try and you want to see if you got it right. So here's what you should have for your visual. 3 x's, a y squared, 2 negative x's, and 4 negatives. So notice the shading. The 3 x's are shaded in, they're positive. The y squared is shaded in, but the 2x and the negative 4, they're empty, they're white. What are the terms? Well, we got 3x, we got y squared, we got negative 2x, and we have negative 4. What are the like terms? Well, the x's, so the 3x and the negative 2x, those are the same. And do you see anything else? I don't think I see any other like terms. I think that's it for like terms. Okay, let's simplify. Let's take things off. Well, we can take off 2 positive x's and 2 negative x's because that's a bunch of 0 pairs. And if those go away, look what we're left with. We still have an x, we still have a y squared, and we still have negative 4. So x plus y squared minus 4 is your solution, is your simplified expression. How'd you do on your own? Did you make any mistakes? If you did, go back and find your mistake and see what was it that you were thinking. Try to figure out what you did differently. See if you can not make that mistake again the next time you do this. Okay, let's try another problem. Example 2. How about this? We're going to simplify. We're going to work on this. 2 minus x minus 3 plus 4x plus x squared. Let's go through our steps. So we're going to do all 4 steps starting with the visual. The visual is going to be 2, so we need 2 little units, shaded because they're positive. Minus x, so that'd be a negative x. Minus 3, so that'd be 3 negatives. Plus 4x, so that'd be 4 shaded x's. And then plus the x squared. X squared means it's the big x squared tile. It looks like this, and it'd be shaded. Okay, what are our terms? Well, we got the 2, so we got to write that down. We got the negative x, we got the negative 3, we got the 4x, and we got the x squared. So we make a list, and we put those commas in the middle, and there's our terms. What are our like terms? Well, matching tiles would be the 2 and the negative 3. Those are the same tiles if you look at the picture. Other matching tiles would be that negative x and those 4 x's. If you look at the picture, they're also matching. So I think those are our like terms. Let's simplify now. Let's get rid of all the 0 pairs. So what can we get rid of? Well, let's see here. We could get rid of an x and a negative x. Together they'd make 0. We could get rid of units, a plus 1 and a minus 1. In fact, we could do that twice, a plus 1 and a minus 1. So if all of those were to go away, I'm going to cross them out on my picture. What's left in this problem? I still see a negative 1. I still see 3 x's. I still see an x squared. So we got negative 1 plus 3 more x's plus the x squared. That's our simplified answer. All right. Okay, so now that we've simplified it, let's do a little bit more work with it. There's our simplified answer, negative 1 plus 3x plus x squared. Now I'm going to add some new directions. Let's evaluate the expression if x was equal to 2. Suppose someone told you what the answer was. They said, hey, I know what x is. X is equal to 2. Can you evaluate this? Here's what that means to do. We take the problem, negative 1 plus 3x plus x squared, and now that we know that x is equal to 2, we're going to replace x with 2's because we know what it is. So instead of negative 1 plus 3x, it's negative 1 plus 3 times 2 plus 2 squared. And now we evaluate. Now we do our math. We do 3 times 2. We do 2 squared. We do that math. 3 times 2 is 6. So we have negative 1 plus 6 plus 2 squared. We do 2 squared. 2 squared means 2 times 2. Well, that's 4. So we have negative 1 plus 6 plus 4. Now we add it up. Negative 1 plus 6. Same signs, add and keep. Different signs, subtract. Okay, these are different signs. We got to subtract. 6 take away 1 is 5. And 5 plus 4 is 9. So our answer is 9. Look at my work. I went step by step by step when I wrote it down. Your work should look the same. It's super organized. It drops down a step every time you do a math operation. And if some stranger grabbed my paper and looked at it, they'd totally understand my work. They'd be able to read it and follow what I was doing. And that's what I want my work to do. I want it to stand alone. I want anybody to be able to read it and know what I'm up to. Okay, so I want you to practice. I'm going to give you a you-try. Here are your directions. Can you evaluate 9x minus x squared plus 4 if or when x is equal to negative 5? So again, I want you to hit that pause button on your device, and I want you to try it by yourself and see if you can do this. Go ahead and give it a try. Alright guys, you're unpausing the video. You are ready to check your answer. You're ready to see if you did your steps correctly. Here's the process. You copied down the problem, 9x minus x squared plus 4. We know what x is. It's negative 5. So we're going to put a negative 5 in where the x's are. So instead of 9x, we're going to have 9 times negative 5 minus negative 5 squared plus 4. Okay, now we got to do some math. 9 times negative 5. 9 times 5 is 45. So this will be a negative 45. Then we have minus negative 5 squared plus 4. Negative 5 squared, negative 5 times a negative 5 is a positive 25. So we have 25. So we have negative 45 take away 25 plus 4. Well, negative 45 take away 25, you can KCC it, keep, change, is like negative 45 plus negative 25. Same signs, add and keep. That'd be negative 70 plus 4. Combine that together, that's negative 66. So your solution is negative 66. Hopefully that's the same thing you got. If not, see if you can find where your mistake was. See if you can kind of pinpoint that error. Alright guys, so that's kind of wrapping it up for this video. Big takeaway here is if you have an expression, you can draw a picture with algebra tiles to be your visual. The terms is like a big list of items in the expression. The like terms are the ones that match up. The matching terms, they're like the same algebra tiles. And then when you go to simplify, it's all about combining the like terms and getting rid of the zero pairs. So we're definitely going to practice in class, but I hope you were able to take some ideas away from this video, and I will see you guys next time. Bye.